watch your language, everybody. So, oops, a pen. Fun with fractions. And so the first thing we have to address to have fun with fractions is we have to answer the question, what is a fraction?
Part of a whole number.
Part of a whole number. That is a wonderful part of a whole number. Anybody else?
Well, the books is an extension of the whole number.
Extension of a
A
whole
natural extension of the whole number.
of the whole numbers?
Numbers.
Ah, natural extension of the whole numbers. So like the integers are a natural extension of the whole numbers when we realize that some subtraction problems don't work with whole numbers. And so let me write that down. A natural extension of the whole numbers. And actually I'll come back and address that later. Kelly had something to add. Part of a group? Yeah, that's another way to think about it. Part of a group.
Percentage.
Ooh, a percentage is a kind of fraction. Yes, that is true. Percentage.
Would that make a decimal part of it too?
Is a decimal a fraction?
Yes.
Ooh, the answer is yes, it is. It's a very cleverly hidden fraction. We'll get to that in more detail later. So we could say percentage, decimal. Anything else you can think of about what is a fraction? We'll explore these in more detail in a few minutes. But. Okay, that's good. Let me see. Can I add anything to this? Yes, I can. Again, under the heading, what is a fraction? It's a division. So, for example, I might have 2 candy bars, and I tried to make them the same size. Not that bad, not that great. Maybe I can shrink that one with the power of technology. That better? It's a little long. What do you think? Close enough. Okay. So I have 2 candy bars, and I go home. There's 3 women in my house that want candy bars. Uh-oh. What I could do is carefully slice them so that they each get an equal portion. So I'm dividing this, right? Okay. So what I have a picture of here is 2 divided by 3. Right? 2 divided by 3. How else can we write it? 2 divided by 3. Okay. We have a few different ways to write division. 2 of them we commonly call the fraction bar. This one is nice because it's on a computer keyboard. This one isn't exactly. This one is not on a computer keyboard. And we do a lot with computers these days, don't we? I was shocked when my 1 second grader had to take a standardized test on a computer. Actually, I was appalled. Still working on spelling, and now we have to learn to type. Anyway, can you see the division here? Right. And so I could put some imaginary lines in here. If I put a dotted line there and there, you can see I was imagining slicing thirds, and each person got 2/3 of a bar. So that's a slightly, is that an unconventional way of thinking about fractions, you think? Or is it kind of, hey, wait, that's kind of common, that happens a lot in my life. Yeah, that kind of happens a lot. We don't usually see that picture in textbooks, but it's a thing kids do, it's a thing people do in terms of division. Usually when we're thinking about fractions with division, like 2/3, it's 2/3 of a whole thing. And for some reason, we are wicked fond of circle-y things with fractions. The problem with circle-y things of fractions is I have a heck of a time making thirds. How's that? That's not bad. And then I am interested in 2 of these thirds, like maybe this one right here, and this one right here, perhaps. And so there's one way to draw 2/3. I love circles, they're beautiful. Might I ever get a tattoo? It probably has something to do with a circle, but that ain't happening today. Often, I find it easier to draw lines, and so usually when I'm trying to illustrate things with fractions, I'll often draw a square cake kind of thing. And then I usually have a slightly better time of deciding where thirds are, thinking of like a number line across the top, and then I can come down and say, okay, yeah, there's my thirds. And I find that a wee bit easier to draw. Texted your mom this, Hillary? Excellent. So I need to select 2 of these thirds, and maybe just to be a little different, so I'm going to pick those 2. So there's part of a whole, which is kind of the most common perception of fractions. Kelly made a good point. Not everything can be shaded in. Like, usually when we're talking about people, we don't like shade half the person. We usually want the whole person. We don't want to cut them up. And so it could be part of a group. Oops. And so I might have, switch colors for fun. 2 out of 3, oops, 2, there we go, out of 3 people here are male. That's making the biased assumption that men don't wear skirts. Some of us do. It's called a kilt. I've always wanted a kilt. I've never gotten around to getting one. My wife won't buy me one. Oh well. Maybe she's. All right, so we're going to stick with gender stereotypes here and say the blue ones are boys and the red one's a girl. 2 are male. There's also another fraction hiding in this picture. Does anybody want to see if they can tell me what it is? 1/2 is hiding in here. Yes, how is that?
Because there's 1 girl and 2 boys.
1 girl, 2 boys, yeah. So that leads to a slightly different way of talking about fractions that we didn't mention, the idea of a ratio. So I could talk about the ratio of girls to boys, which sometimes we'll write it with a colon. Remember seeing something like this in your past life? Girls, colon, boys. And so they'll write something like 1 to 2, which we could also write as a fraction, number of girls over the number of boys, which is 1 girl for every 2 boys. And that's not a part of a whole group, it's not a part of a whole, it's just a ratio, girls versus boys. Is that a useful thing, do you think?
Ratios?
Yeah, it's a ratio. Yeah, they're pretty useful things. We use them in lots of places, whether it's saying what part of a population is male or female, or whether we're talking about a recipe, like I like to make pizza, and my typical pizza dough has 1 cup of water for every roughly 3 cups of flour, and if I screw that ratio up, it's not going to be very good dough. Right. Kelly, you have a comment? Oh, how many are in a classroom? Yeah. Girls to boys in a classroom, yeah, exactly. And it could scale up, like it could be a particular class has 10 girls for every 20 boys. It's the same ratio, it's just a different way of writing it. So this idea is another one we'll deal with soon, equivalent fractions. Okay, let's see. So what do we have for what is a fraction? We've got a ratio. We've got a part of a group. We've got a part of a whole. We've got a division problem. So far we have 4 ways to model what a fraction means. And that is super important, because what's one of the hardest things in math kids struggle with? Fractions, that F word, yeah. People struggle with fractions. Like when people come up here and take the placement test, they mess up fraction stuff and they place lower than they should because they didn't practice ahead of time. They're easy to mess up because they have complicated rules. Addition and subtraction have certain rules. Multiplication and division have certain rules. And multiplication is really not quite like division with fractions, and neither of them are like addition and subtraction. It's like the most complicated thing to play with in terms of numbers. Excuse me. Turns out there's another model that we haven't quite talked about here yet. Division, part of a whole, part of a group, ratio. Assuming nobody's read section 1 ahead of time. Oh, Greg, man, look at this guy. He's all over this.
Number line is everywhere.
Number line is everywhere. Yeah, number line is another model for fractions. So we have 5 models for what is a fraction. And so a fraction is a position on a number line. So before...
So would you be able to use a negative number in a fraction on the number line?
Oh yeah, negative numbers and fractions, yep.
On
Yeah,
the number line?
I'll draw a picture of that in just a second. So like if I was stuck on 2/3, well, somewhere in between 0 and 1, I whip out my ruler and I do my best equal parts here. Let's see, that is almost 27. So then every 9, there, there. And so there's help there. So this position is 1/3, that position is 2/3 on the number line. This also helps me jump out of the part of a whole thing, because there are some fractions like out here. That guy right there, I believe, is 1 1/3. Or if I count by thirds, I have 1, 2, 3, 4/3 would be another way to talk about that particular position. And they both have their uses. Which better? 1 1/3 or 4/3? You think 4/3 is better?
I think when you're teaching elementary school, because I think they'll grasp 4/3 as opposed to 1 1/3.
4/3 is an improper fraction.
Okay, so you're saying this one right here is improper?
Yes.
Okay. I highly discourage the use of the word improper with fractions, because like when I tell my kid they're being improper, I might send them to the principal's office next, or they're going to go to timeout or something like that. Maybe we could call it top-heavy.
But then if you think about it also, when
So
you
you're saying
give
it's
them,
bad?
if you give them a,
Okay, let's stick with improper.
if you give them that, they might see that like 4 has one.
One
Part of 3.
more extra, yeah, right. Yeah, so there's definitely a relation going on there, and we definitely want to get that relation across, and we'll play with toys to help get that relationship. And the answer is neither is really better, it just kind of depends. Like suppose I was giving you directions to my house, and I said, drive 4/3 miles from BMCC heading east.
Where's east?
Okay, wouldn't it make more sense to go 1 1/3 mile east from BMCC, right? That, in that context. However, if I need to do a calculation with a fraction, I'm much better off using 4/3. It's a much safer number to work with than 1 1/3. So there's sometimes 4/3 is a better way to write the fraction. There's sometimes 1 1/3 is a better way to write it. So it kind of depends. The 1 1/3, by the way, is referred to as a mixed number, right? Christian, you got a comment?
Well, I'm curious. So would you say that if someone was trying to do distance or height or something like that, it'd be much better to use that versus the 4/3, because then they're counting 1, 2, 3, and then a third of that next number going to that location.
Yeah, so talking about distance, I think it sounds better to me to say drive 1 1/3 miles, or to say I'm 5.5 feet tall, than it does to say, what would that be? I'm 11.5 feet tall. Well, doesn't that sound weird when I say that? 11.5 feet tall, 5.5 feet tall. And part of it's just convention. We just get used to saying things that way. If we grew up and people said 11.5 more often, we'd be like, oh yeah, okay, I get it. I get what you're saying. So part of it's convention. Sometimes there's a reason to why we might prefer one over the other. And we'll get more to that as we do calculations for fractions. All right, so summarize. We have 5 models for fractions. We have the most common, I'll write first, which is part of a whole. And usually when we talk about that part of a whole, we're usually talking like a cake or a pie kind of thing. So I might say part of a whole area or region. I'm going to throw area in there because I like that word. Which can be different from part of a whole group. This came up when we were playing around with multiplication of whole numbers a while ago. The area model versus the array model is what these are related to. Does anybody remember the mathematical words that are related to area and array? There were 2 math concepts I spent a little while talking about when we got to this part of multiplication last term. I'll tell you what they are, and you tell me which word goes where. One of the words is discrete, the other word is continuous. Which one of these models is discrete and which model is continuous?
Whole is discrete.
That whole is.
No, I think the whole is continuous. The area is continuous.
Area is continuous, yeah.
Oh, because
So that's because yeah, it's just filled up with paint, right? Kind of thing. Whereas a group, I count them, and discrete means countable. Yeah. So this is the first one right here is a continuous model, mathematically speaking. And the second one is a discrete model. Not discrete like don't mention this to my wife, but discrete as in pieces. It's a different discrete. A fraction could be a division, slicing things up. A little bit different than these other things. 4, it could be a ratio. Boys to girls, miles per hour. Or 5, it could be a position on a number line. And then what will happen is once we talk about addition, subtraction, multiplication, and division, we'll say, okay, let's pick one of these models and see if we can use it to show why we have to add, subtract, or multiply, why do what we do. And so we're going to try and justify a fraction, addition, subtraction, multiplication, and division. Let's see, some other ideas that we need to talk about. I mentioned equivalent fractions. We're going to play with that. So now we have some toys to play with. So let's have me stop babbling so much for a minute and have you all take a look at some projects. Debbie, do you have your workbook nearby?
I do, yes.
Okay. And Kelly, let's see, you can. Okay. Is it very far or?
Not too far.
Okay. I'm going to make some copies for Kelly. So we're going to take a look at activity 1. And let's see, do I have a copy of it here on the computer? Sometimes I do.
Gosh, this is like, it's gonna make you think.
It's going to make you think, absolutely.
Trapezoid, I don't know how many sides that has. I know the hexagon has 8.
Okay,
Right?
6. I think this is
I'm trying to tell you.
yes.
A rhombus?
A rhombus? That's like this.
A rhombus. Okay.
It's kind of
So-
centered. Yeah, like
So here's activity 1. We're going to play around with pattern blocks and some other pictures.
So I actually have bags of pattern blocks here if anybody wants to grab some to play with. I would highly recommend it for some of these activities. I found some of these activities make my head hurt if I don't have the physical toys nearby.
I agree with you.
So you don't need the clear ones, and you don't need the square. Well, yeah, you don't need the squares either.
Okay, what's it?
Here.
There's only, there's 4 of them?
Just these ones.
Got that one. Oh, I need a Mexican, well, I guess we could.
We need 3. Oh, Greg, way to just jump out there and grab them.
Why not? You got a billion of them.
I know.
What else I need? Maybe a few of them or just one of each? How do you only need 3 of those?
Because 3 of them go into a hexagon.
Oh,
Maybe
how
you
are we
can
gonna make a rectangle? I need 4 squares,
You triangles for it.
and I need squares, don't we?
I think you see those. I don't see any squares.
Number 2.
Oh, there's squares.
Yeah.
Yeah, well, squares are squares and we all know
Squares are
those.
orange.
You can put in some.
Okay, what's up? Question?
Why?
I lied?
I need squares.
We do need the squares? Oh, okay.
Number 2 is
Oh, well, okay. You don't have to use those squares for it. Okay, the other thing we're going to need are what are called color rods. And, oh, Debbie, I'm sorry, you can't see those toys. At the end of the workbook, there are cutouts. And you want the cutouts for pattern blocks, which is sheet 3 and something else. Let's see, do you have the workbook with the little plastic pouch?
I do, yes.
Okay, yeah, so let's see, number 3. Maybe I'm missing my number 2. Oh, there it is. Sheet number 1,
Squares, yes.
sheet number 3, and maybe sheet number 4. Those are the pattern blocks. And then there's another one called Cuisenaire rods. And they're often called color rods. Let me get a picture of those online. Browser. Let's see, do I have them?
Strips.
And then, yeah, there's fraction strips
I'm
also.
gonna tape that on their desk.
Online manipulators, maybe. Pattern blocks. So pattern blocks, sometimes they're called color rod. Oh, shit, that's the wrong one. Oh, I said it. I was trying really hard to behave myself. Okay.
As you can tell her, there's she logs into the book. There's an e-manipulator that's built into the book.
Right. Ooh,
It has
what did I
the
just
same-
do? Okay, so are these the right colors? I think these are pretty, oops, stop it. So you should see a bunch of color rods, like a big orange, followed by blue, brown, black, green, yellow, purple, green, red, white.
Yep.
You found those? Okay. So let me get my virtual ones. Oops, wrong button.
Wait, what do we need? Do we need those?
We eventually, for the next page, we're going to need the color rods, the Cuisenaire rods, which I'm getting virtual versions here. Yeah, and there's the color rods are in the plastic boxes over there, if you want to grab some.
Can you tell me how many sides of
Greg, would you like better?
Trapezoid has 4 sides.
4, so it's
Sure.
square.
No, it is not a square.
No?
It is it's that red thing.
Sorry.
That's a trapezoid.
Oh, thanks. Oh, we got a brand new one, hasn't been opened.
Yay.
Hello?
So these are called Cuisenaire rods or color rods. And pattern blocks, copy address. Paste it over here. All right, so the main ones we're going to need for the activities, we're going to need the hexagon, we're going to need the trapezoid, just a couple is fine, a few trapezoids, a couple of rhombuses, and a couple of triangles. The main reason I'm picking out these four compared to the others is these four fit well together fractionally, whereas the skinny rhombus and the square, although they have the same side lengths as the other one, area-wise, they don't play nice together. So with fractions, I won't be doing as much with those. If we were doing more with geometry, I'd be playing with these guys more. Go away.
So we can just put those away.
Oop. I want it to go away.
Are we not?
Oh, there it goes. And technology is not being my friend today, but you can just sit there. And I probably should find a way to blow this up. How about that? Aha, that's better. Okay. All right, back to that activity. So we're just kind of playing around with the idea of a fraction, and mostly we're thinking of part of a whole here in terms of the model for a fraction. And so we're asked some questions about the pattern blocks. The trapezoid is what fraction of the hexagon?
Half.
Half? Okay, so where did that sucker go? The trapezoid is what fraction of the hexagon? And so we can line them up and put two of them there and see that, yes, indeed, two of these things make a hexagon. Okay? And so with kids, we want them to actually physically grab these toys and stick them on top of each other and say, hey, look at that, they match. So play around, feel free to work ahead of me here. The blue rhombus is what fraction, is what fractional part of the hexagon?
Those are red, it's a trapezoid.
What's that?
Where's Blue Rhombus?
Oh, that's why I asked you to go grab these toys.
Well, I got them, but.
Oh, you grabbed some, okay, you just didn't take them out yet.
Share some of the greens, please.
So I'm gonna paste this into my little notebook. Nope, wrong button, there we go.
Trapezoid is correct.
It's what fractional part of the hexagon? So half.
So when
I
they're
lost
asking
my
you for the
magic.
shaded,
Oh, you're already on the next part? You're flying, hang on, let me catch up. Anybody see my magic pen anywhere? Oh, there it is. Okay, so let's see, we've got 1/2, one out of 2 parts. That guy. The blue rhombus, how many blue rhombuses fit inside a hexagon? 3. 3 of them? So it would be 1 out of 3 parts to make a whole hexagon. How about the triangle?
6.
1 out of 6 parts. So the triangle is 1/6 of the hexagon. How about the triangle as part of the rhombus?
Half.
It's 1/2? No.
Yeah.
All right, and we can show that with the toys. I'll bring that up in a sec. And the triangle is what part of the trapezoid?
Third.
Third. And I'm going to add another question here just for fun because Hillary's kicking some butt here. Should we make it an easy one or a hard one? Make it a hard one. The trapezoid is what fractional parts of the blue rhombus?
2/3.
You are just flying. 2/3, you think? We have one answer of 2/3. Anybody else?
Trapezoid?
The trapezoid is what part of the rhombus?
It would be 1/2.
1.5?
1/2 piece into this, but which way is it going there?
The trapezoid.
The trapezoid is what part of the rhombus? Now let's think back a sec. So the trapezoid is what part of the hexagon? Which is bigger, the trapezoid or the hexagon?
Hexagon is half.
Yeah, so it was 1 out of 2 because the trapezoid is smaller. Now we're changing the base. Which is bigger, the trapezoid or the rhombus? Trapezoid, so we have a bigger thing being part of a smaller thing, so that should be a top-heavy fraction,
Oh, so then it's.
okay? So let me bring up my cheat sheet here. So the trapezoid is what part of the, how do I get you to go on top there? Oh shit, what did I do?
You pull up another one so that it'll be mixed.
Okay. Ooh. Pull up another one. Ah, thank you very much. Yeah, so we can see that it's bigger, right? And so Christian's idea was, ooh, the trapezoid is 1.5 rhombuses. Can you see the half a rhombus here if I bring up a triangle?
Mhm.
See it now? The triangle is half, there's an extra triangle there. So the trapezoid is 1.5 rhombuses. There's one whole rhombus and then a half a rhombus there. The other way I could think about it is if I use the triangle as the common denominator, how many triangles fit in the trapezoid? 3. How many trapezoids fit here? 2. So I could say it's 3 halves. So there's a bunch of ways to phrase that answer. 2 actually, in this case. So I could say it is 3 out of 2 parts of the rhombus, or I can say it's 1.5 rhombuses. Depending on how I look at it. Double checking that back here with the trapezoid versus the hexagon. If we use the triangle as the common denominator, how many triangles are in the trapezoid? 3. How many trapezoids are in, how many triangles are in the hexagon? 6. So my claim is if the triangle is the common denominator, the trapezoid is 3/6 of a hexagon. Does that match with our idea of 1/2?
Yeah.
3 out of 6, 1 out of 2. Okay. Kids will catch on to that with the toys pretty quick, and that's going to help us teach them the idea of equivalent fractions. Okay, moving on. We've got those shaded areas to play with. Screenshots. So some of you I see we're working ahead, so you can help me out here. Let's see, so we want to do fractional part shaded versus fractional part unshaded. So what part of the hexagon is shaded here? 2 out of 6 parts. And so I could just kind of double check that by either whipping those toys out, or I could draw on here some more divisions. And so then I can see there's 1, 2, 3, 4, 5, 6 pieces. 2 of those 6 pieces are shaded. And then how many are unshaded? 4 out of 6. Now, would you agree this figure is either part is either shaded or unshaded, right? So altogether, when I put the shaded and unshaded together, I should get a whole, shouldn't I? How many pieces are in a whole? 6, 6. So this gives me the idea that if I take 2, 6 and I combine it, because isn't addition combined, with 4, 6, I should get 6, 6, which is also one whole. So these toys can help lead to the idea that when you're working with fractions, the numerator is pretty darn important, provided you have the same denominator. We'll deal with when we don't have the same denominator later. But with kids, you work on a common denominator for a long time before you even address uncommon denominators. All right, so you guys can figure out the rest of that. I'm just going to skip ahead. All right, so what's the next fun part? Okay, so now we're playing with the Cuisenaire rods, and here's where it gets interesting. It's a little more challenging.
It's just working with
Ooh, okay, so you said working with tenths can help here? So let's see, I need to steal a snapshot. Where did I put that?
Because why? Because there's 10 white ones in the orange one.
Put up like the 2 yellow ones that I have, and you go down to
Well, yeah, but what green one are they looking at? This green one or this green?
Yeah, so since they mentioned dark green below, I'm assuming that's the light green up there, just green versus dark green.
I didn't see the dark.
Yeah, that could be written more clearly. Agreed.
I thought they were set up moss or something like that.
Okay, so let's see. The orange is a whole, and so red. So what the thing is, you can play around. There's 2 answers here. you could pick up the red and see how many of them line up here to make the orange one. And so if I do that, I would see that there would be 1, 2, 3, 4, 5 of them. So I could say the red is what? 1/5 of the orange one. Oh, you said that a minute ago, didn't you, Debbie? Sorry.
That's okay.
I thought it was a voice in my head telling me what the answer was. All right, so what's another answer we could use for the red, though? Christian was alluding to this, talking about the white piece.
Well, I just mentioned it, recognize the 10 piece as 10. The orange one is 10-1.
10-1, yeah, so this is kind of like decimals. Like the white would be 1/10. The red is then 2/10 and 3/10 and so on. Now, depending on the curriculum, kids have probably already seen decimals because they're so much easier to work with. So we could say that the white one is 1/10, which is also the same as 1/10. Greg, can you do me a favor? Could you read for me what I wrote here in red? It's not a trick, it's kind of a trick question, but say it anyway.
1/10 equals 0.1.
0.1, yeah, usually we just call it 0.1, right?
Right.
Like how many of you write just that often? 0.1, right? And we say 0.1. Now I put the 0 in front because I'm afraid of like not seeing my decimal point and thinking that's just a 1. And I would never put a 0 in front of the 1 if it wasn't 0.1. Now here's the other thing, 0.1 is slang. It's like saying ain't. Or saying.
It's in the dictionary.
It's in the dictionary now? Okay, well, it ain't slang anymore, I guess. So, but anyway, it's mathematical slang. The correct way to read either this guy or that guy is 1/10. That's the proper way to read it. And we'll talk more about that when we get into the next chapter.
So that A would be should be 1/10.
So, no, the red piece would be 2/10. So I could also call it 2/10. I could also call it 1/5. I mean, I've got two names for that fraction. It could be called 1/5. It could be called 2/10.
So then when you have a, like, so such as the green one, when you have one extra green one, because you can get it.
Oh, working with the green one. Yeah, the green one is a little bit problematic. So let's do
Because you can
that.
get 3.
Let's see, I'm going to switch tools here. Let's go to my virtual tool.
The light green ones.
3 1/3.
Yeah, so if we look at the green one, I try to line them up here. So there's one green one. There's another green one. There's another green one. I can't fit them in there nicely like I could the 2. And so this is where Christian's suggestion comes in, that we have to use the 1 piece as a common denominator. And so we know 3 of them live inside the green piece and 10 of them live in here. So what we can say is that it's 3 out of 10.
3/10.
The green is 3/10. Now Hillary really wants to say 3 1/3. So let's think about that for a minute too. So I'm going to write it down both ways and see what happens. So let's see, we're on, let's see, this guy right here. Let's switch colors. So if I use the common denominator idea, then the green is 3 out of the 10 that the orange one has. Okay, let's see, what else can I do? I can also say that I need, let's see, how many of those yellow ones fit inside the 10 piece?
2.
Sorry, how many of the green ones? I don't know. How many of the green ones fit inside the 10 piece? Hillary?
3 1/3.
3 1/3 of them, right? So 1 green is the same as 3 1/3, which is live inside the 10, right? So green. So what if I use the green as my denominator? Then my fraction would be 1 compared to 3 1/3. Because there's 1 piece here, and there's 3 1/3 pieces there. Now, this is something we wouldn't do in a classroom with kids who are first doing fractions, but you guys are very advanced fraction users. So let's see if we can make sense of that 1 out of 3 1/3. This is called a complex fraction, because it has a fraction within a fraction. That's a problem. And earlier I said, if I have to do a calculation with fractions, I would much prefer a top-heavier improper fraction. So how would I write 3 1/3 as an improper fraction? It would be 10 thirds. Yeah. So that means what I really have is 1 over 10 thirds. Now that's really 1 divided by 10 thirds. How do you divide with fractions? Anybody remember the rule? You flip what?
The second one.
The second one, yeah.
And then you change it to multiplication.
And then you change it to multiplication. So this is really 1 times 3/10. 1 times 3/10 is just 3/10. So Hillary's notion that 3 1/3 greens fit inside the 10 piece actually works out, but you got to do some serious math to get there. Right? So some kid might notice that, but this would be too much to do in an introductory fraction lesson with kids. Later they could do this, after they got down fraction division. Then we could say, hey, remember way back when we were first dealing with fractions? And you could show them that picture again, and then you could try and take them through all of this. Right, so that would be more advanced. All right, strong button. All right, let's see, what else do we have here? So yellow, that's not too bad. We could call that 5/10 or 1/2. And then the purple is the 4-piece. What are we going to call that? The easiest thing to do is call it 4/10. Okay. Or you could try and line it up like Hillary did and be a little wild and crazy and see if it works out. We'll skip that for now. We'll come back to that later. All right, so I'm going to copy some of this to a new page so we can do the next part. All right, so we're changing the denominator. The purple is now a whole. So now our whole world changes because we have to compare everything to the purple as one whole. So let's make a note. So if we tried to talk about yellow compared to the purple, that would be an improper fraction because yellow is bigger. Versus if we talk about the green, the light green, that would be a proper fraction because it's smaller than our whole. So let's see, the brown piece. Is the brown piece bigger than my whole? So that's going to lead to an improper fraction or a mixed number. So how many 4s fit inside, how many purples fit inside the brown?
2.
2 of them. So that means it'd be a ratio of 2 to 1, which we could just call 2. Have everything 2. 2 is an excellent answer. Let's see, what about, orange. What can we do with orange? Let's see.
2 1/2.
2.5? Could we just call it that? Let me just double check on my toy screen here. So let's get rid of these guys. And throw in some 4s. So there's 1 whole 4, there's 2 whole 4s, and then we can't quite do a whole 1, but it looks like we got half a 1. Yeah, so we could say an orange is 2.5 purples. Okay, there's another way we can look at that though. If we use 1 as the common denominator, so we could say it is 2.5 purples. On the other hand, how many 1s are in the orange? 10 of them. And how many 1s are in the 4? 4. And then we could write that a little bit different though, right? Because how many people are dying to reduce that? Now your kids aren't going to know about reducing yet. So is there a way we use the toys to talk about reducing? What could we use instead of the 1 as a common bar?
The 2.
The 2, yeah, we could line up the 2. How many 2s are in the 10? How many reds? There's 5 of them. And how many of the reds are in the purple?
2.
2 of them. So right now, we have 3 different ways to express this relationship. Now let's see. What's another interpretation of a fraction? There were 5 of them. We're doing part of a whole now, which is kind of like part of a group. Ratio is another one. Number line is another one. Or Division, yeah. And division is the link between these two. At least it's one of the links. Okay. We can clearly see picture-wise the 2.5 and the 5 halves, right? Everyone can visualize that with the toys. If we do long division, 2 goes into 5, we'd say 2 goes into 5, what, twice? 2 times 2 is 4. We subtract and get 1 left over. So there is the 2 with 1 left over. 1 out of what? 1 out of 2. Prior to this point in our kids' lives, they were just writing 2 remainder 1, right? We are now about to be officially done with that silly remainder. And we're going to say, oh, it's 2 and a half, and 1 out of 2 left over. So we'll spend more time on that later. Kelly, question?
I was thinking last week, graders,
Fifth graders,
they
yeah.
were doing fractions, and she was having them do the fractions, so.
Okay, yeah, write them with the fraction instead of with the remainder, yeah. And yeah, once they get fractions, we're done using remainders pretty much. We don't just say it's 2 remainder 1, we say it's 2 and 1 out of 2, or 1 out of 3, or whatever the denominator happens to be. Another comment? What's that? What grade? My guess is they stopped doing that in 4th grade, but I'd have to look at the standards to double check. But I think it's 4th grade they start getting into fractions and division. All right, let's see. How about the black one? What do you got on the black? Anybody? There's a couple of answers we could write there.
1 3/4.
1 3/4 is one of them,
7/4.
or 7/4 would be the other one. Yeah, good. 1 3/4 or 7/4. And again, with kids, we're really, and even with adults, lining these pieces up is critical in kind of getting these relationships. Depending on how we line them up, we can demonstrate that the black piece is 1 3/4 of the purple piece, or it's 7 out of 4 compared to the purple piece. How about the dark green? What happened on that one?
1.5.
1.5 or 3/2? Did anybody else get a different fraction on that one? I was thinking like the white piece, that it would be 6/4. Now, it didn't ask you to write every single possible combination. I'm just kind of brainstorming here, having fun with it. But can you see how we could justify the 6 out of 4? There's 6 1s in the dark green. There's 4 1s in the purple. So there's multiple answers we can justify. You just need to throw one of them in there. You don't need all of them. All right, how are we doing here?
Can you help me with number 4?
Ooh.
Oh, you're brilliant.
Okay, so you're down in this next here.
Yeah, so I changed it to top heavy.
Let me catch up. I'm gonna book. Page, screenshots.
It's really just.
Okay, so we are, so number 4 is the one you're thinking about?
Yeah.
Okay. So number 4,
So I-
if the white rod is a 4th, which rod would be 1 3/4? Okay,
I
so we're
changed
saying,
it.
let me just catch up. So this guy right here is gonna be the same thing as a 4th. And then we wanna figure out what piece would be 1 3/4.
7 white.
So let's see, so I just wanna go back to something you've kind of seen before.
Oh wait, so you, oh, okay, I get it now.
You get it now?
Yeah,
Yeah,
I was
so,
trying to figure out which one would make, because I changed it to 7 points.
yeah, you could write it as 7/4, or you could leave it as 1 3/4. So if I'm going back to play with my toys, here they are, and I'm playing with the 1, then I would need some more of them. So that's a quarter, right? So now, if I put how many together to get a whole? 4. I would need 4 of them to get a whole. So here's my 1. And then I need to get 3 more of these to get the 3/4 part. Okay, so there is 1 3/4, which altogether is 7, which means it has to be the black piece, just the one they're referencing there. Now, I just want to have a little bit more fun with this problem since we're on the subject. Hillary, can you read to me this number right there?
What I'm doing.
Okay, so you said 1 and 3/4, right?
Yeah.
Okay. And doesn't that usually mean plus?
Yeah.
Okay. And 1 is how many fourths?
Cool.
Right, it's 4/4. So I could say that's the same thing as 4/4 plus 3/4. So how many fourths do we have altogether?
7.
We have 7 of them. Right? Now, most people somewhere in their lives learned a shortcut, and that was to take this number times that number, and then they add the result to the top. Okay. Which is pretty much what's going on in this series of steps right there. I'm just lengthening it out. But it kind of makes sense in the way we read a mixed number. We do say the word and, which we usually refer to as addition. All right, any of those other ones puzzling in this next part?
So if the red one is half
The red one is a half.
over 5, and you need 1.5, so you have to do
Need 3 of them.
So we
Put
need
3 reds together.
Yeah.
Equal.
the dark green.
Exactly.
Yeah, so 2, if a red is a half, so there's now a whole, I want 1.5, which means I need something with 6 pieces altogether. So that would be the dark green one.
Isn't the same answer as number 2 then?
Oh yeah, there's multiple ways to throw these together. Like we could spend all day messing around with stuff like this.
Trying to get tricky.
I know, it was really stressing me out for a second.
We'll be spending the whole term messing with stuff like this, so.
We will, yes, the whole term messing with stuff like this.
But
Fun
orange
with
for the last one?
fractions.
Perfect. Me too.
Okay.
I like to use. Didn't you?
All right, so I'm gonna let you guys finish this next part. I wanna jump on to the next lesson. And this recording is getting a little long. So Debbie, I am gonna close this Hangout and start a new one. So you'll get a little ding dong message about it in just a moment.
Okay.
And I'll be right back.